Hello, I just wanted to create a short video because there are a lot of students having trouble with the problem from section 2.2, number 10. And this problem states that we have a limit as x approaches 5 of x squared plus 4, and they want you to evaluate that limit and also use the epsilon delta definition to prove that the limit exists. So the first part is the easy part. Since this is a nice parabolic function, right? It's a nice polynomial. There's no interesting, crazy places that happen. It's a nice smooth curve. Then the limit just agrees with the algebra. We can just plug 5 in here to evaluate the limit, right? So we can get 5 squared plus 4, which is equal to 29. Okay, so that's the first part. Now, the hard part of the problem is to prove that this limit is actually equal to 29. And we start with f of x minus L is less than some arbitrarily small number epsilon. And we want to get from there to the fact that x minus c is less than some delta. So if we can show that these two are related to each other, that if one is true, the other one is true, then we have proven that the limit exists. So we're going to start from this part. And we're going to put in the actual function we're talking about, which is x squared plus 4. And we're going to subtract the limit that we got, what we evaluated that limit at. We got 29. And that's supposed to be less than epsilon. And we want to relate that to the value of c here. The value that x is approaching is 5. So we want to relate to that to the absolute value of x minus 5 is less than some delta. So most of you got partway through it, but there's this one little step that is kind of difficult to understand. So first we're just going to simplify this. We're going to say, okay, this is the same as x squared minus 25. And then you can factor that and say that that's equal to x plus 5 and x minus 5. And all of that's less than epsilon, right? And we want to relate this fact to this fact. And what we can see is that this x plus 5 is sort of in the way. We don't really want that there. So what we're going to do here is we're going to kind of get rid of that by playing sort of a inequalities game. And it states in the problem, and it's important at this step, that they're going to assume that x is between 4 and 6. And the reason they're doing that, and the reason that that's okay, is because, of course, x is just approaching 5. So if x is approaching 5, it's reasonable to assume that x is between 4 and 6. Now, this would actually work. This proof would actually work whether you used any number here. You can make this anything. You can make this 4.1 and this 5.9, or you can make this any interval you want as long as it surrounds 5, and the proof would still work out. Anyway, if you assume that x is between these two values, the important part is that x is less than 6. And the reason that's important is because if x is less than 6, then we can say something about the absolute value of x plus 5. If x is less than 6, then the absolute value of x plus 5, which would be equal to 11 if x was 6. But if x is less than 6, then this is going to be less than 11. And some people say, where did that 11 come from? And that's where it comes from. If x is less than 6, then 6 plus 5 is 11. So if x is less than 6, x plus 5 has to be less than 11. That only makes sense. Okay. So here's the idea. We want to link this statement up with this one over here, right? So our goal is to kind of eliminate this x plus 5 from the inequality, and this is how we do that. If x plus 5 is less than 11, then it makes sense that the absolute value of x plus 5 times the absolute value of x minus 5 is less than 11 times the absolute value of x minus 5. That only makes sense, right? If this is less than this, then this entire statement over here, this entire algebraic expression is less than that algebraic expression, right? That definitely makes sense. Now, what we're going to do is we're going to pick our epsilon here. We're going to say that our restriction for epsilon is that this is going to be less than epsilon. And keep in mind that that also means that the inequality we're working with is less than epsilon. If this is less than this, and this is less than epsilon, it makes sense that this is less than epsilon, right? So as long as we choose, just manipulating this part a little bit, as long as we choose that x minus 5 is less than epsilon divided by 11, right? I'm just dividing both sides of this inequality by 11. As long as we choose that, then we are guaranteeing that this is also less than epsilon, right? So what we have done here is we've linked the fact that this part is less than epsilon to the fact that x minus 5 is less than epsilon divided by 11, and epsilon over 11 is our delta, right? So we've linked the two together, which is what we're always supposed to do. That's the idea of the proof. I hope that clears things up just a little bit and that makes it more clear to people. It is a very confusing one. If you need to email me and ask me more questions about it, please do that. But I'm hoping that video will help a little bit.